The University of Washington's steam generator replacement project was a significant undertaking. Tell us more about this project and how it compares to other campus utility plant projects across the U.S.
Yeah, for sure. So as most of the listeners probably know, there's a national landscape that's moving heavily toward decarbonization. While UW is not independent of that landscape, they have a pretty ambitious goal for decarbonization.
When the University of Washington needed to ensure uninterrupted power for its campus and hospital, they turned to Stanley Consultants for an innovative solution. Tasked with upgrading an aging backup steam turbine, Stanley's mechanical engineers designed a cutting-edge diesel rotary, uninterruptible power supply to enhance reliability, reconfigured the plant's boiler and steam systems for greater efficiency, and implemented a unique mechanical flywheel backup system to bridge a critical 7-second power gap. This forward-thinking approach not only solved a complex challenge, but also earned prestigious recognition from the ACEC. Joining me today is Brad Schmidt, Power Mechanical Department Manager at Stanley Consultants. Brad played a key role in this award-winning project, and he's going to take us behind the scenes and share how his project management team tackled complex constraints, drove innovation, and delivered engineering solutions that underscore the transformative power of creativity in mechanical engineering and project management. He'll also give some game-changing tips on stakeholder engagement, which is critical to be a successful project manager. I'm your host, Anthony Fasano, and this is the AEC Project Management Podcast. Now I'd like to welcome our guest onto the show for today. Brad Schmidt is the Power Mechanical Department Manager at Stanley Consultants. Brad, welcome to the AEC Project Management Podcast.
Yeah, thank you, Anthony.
So, Brad, just to get us going here, can you talk a little bit about your professional background and kind of the journey that led you to your role as the Department Manager at Stanley Consultants?
Yeah, for sure. So I've been with Stanley Consultants just over 20 years now. I started in the mid to late 2000s in the power generation industry. Well, I did a couple coal-fired power plants, and then as that industry waned, I transitioned more to the institutional environment with the combined heat and power. I did some projects at University of Illinois. I did a combined heat and power project for the military that really cut my teeth on industrial size steam turbines. And then also at Texas A&M University, did some combined heat and power, and also here at the University of Washington. That's the project for the subject today.
Yeah, absolutely. That's awesome. So you've had kind of a variety of experience as you progress through your career, kind of different project types. So getting into the project that we're going to talk about today, the University of Washington's steam generator replacement project was a significant undertaking. Tell us more about this project and how it compares to other campus utility plant projects across the U.S.
Yeah, for sure. So as most of the listeners probably know, there's a national landscape that's moving heavily toward decarbonization. While UW is not independent of that landscape, they have a pretty ambitious goal for decarbonization themselves. So keep that in mind as we're talking about their facility. They currently have 5 boilers on site at the central utility plant. Prior to the project, 2 of those boilers produced superheated steam, and 3 of the boilers produced saturated steam. The superheated steam boilers fed 5 megawatt back pressure steam turbine. So it was a true combined heat and power facility. They had the ability to produce a significant amount of steam used on campus for heating loads, as well as power to power the local central plant and the critical users such as the hospital and other campus facilities. The turbine prior to the project was aged. It was unreliable. They had frequent outages, and there were issues with it. It was essentially at the end of life. So we've got reliability issues at the UW Central plant, as well as this landscape that we're dealing with that's moving toward decarbonization. So the project really had to bridge the gap between where we're at now, which is where the university was at, which was an older facility, and the new decarbonized focus. And so that produced a business case where we really had to increase central plant reliability, but we also didn't want to install or spend a bunch of money to install some assets that were just going to be, mothballed or decommissioned a few years later. So not only was it a reliability project, but we also had to consider that assets shouldn't be stranded as well.
Interesting. Interesting. Yeah. I mean, you have to consider the productiveness and the reliability of what you're installing, but also, like you're saying, the environment and everything that's going on right now and how long these things are going to last and be viable and be permissible. So it's certainly an interesting challenge. And I think every project, Brad, has unique challenges. What specific constraints and complexities did your team face on the UW project? And how did they kind of shape the approach to meeting the client's objectives, which we always try to do as project managers?
Yeah, absolutely. So I'll go through three of those challenges here with you, Anthony. The first really relates to the tension between reliability and emerging markets and the migration toward decarbonization. Some of the stakeholders were very interested in pursuing decarbonization even quicker than what the university had in their long-term goals. So they had needs that we had to consider. They had interests that we had to consider. And then there's the reliability aspect. We've got some technologies out there that don't necessarily support decarbonization, but yet they're extremely reliable. They're ubiquitous across the market in combined heat and power. And how do we combine old reliable technology with the movement forward toward decarbonization? So we had to again balance those stakeholder interests, and that was really a huge part of project execution and one of the unique challenges. The second was related to the fact that the central utility plant really didn't have the option to sustain an electrical outage. If the plant lost power, the central plant would require at least 5 hours to get steam and some other utilities back to campus. So one of the primary focuses and constraints was to install a system that was essentially blipless, where it would sense the loss of power from the electrical grid and be able to ramp up generation and provide power for the central plant as well as those critical needs such as the hospital. So one more unique challenge, and I think we may hit on this a little more in the future part of the session here, but the existing facility has unique challenges. It's a very aged building. It's built onto and expanded many times, and installing a 40-ton piece of equipment in an existing facility, finding the space as well as finding the structural to support it can be a challenge. Also, the integration of state-of-the-art switchgear into old electrical gear that also can be challenging. So that there was a lot of intricate details that had to be thought through. A very rigorous commissioning plan had to be implemented in order to integrate the state-of-the-art switchgear into the older facility so that it would integrate with the existing gear.
Interesting. And, this is really what project management is all about, in that you have these different stakeholders, right, with different interests, different influences on your project, that you have to navigate some of these challenges with, specifically, let's say the decarbonization issue versus reliability issue, which is certainly a big one that you have to manage as the project manager. And then, oh, by the way, we're still running a technical project and we have a lot of technical things and challenges that we need to consider, like Brad just took us through with that last challenge. So definitely a very interesting project for a case study here, because you have the amplification of that really what I think is a big challenge in terms of wanting to build the most reliable and value engineering and sustainable type of project from an engineering standpoint with decarbonization in mind, and then still doing all the technical work. So, Brad, your team developed a unique mechanical method to store electricity and bridge the 7-second gap, which I'm sure you could explain for us. How did you identify this need and innovate a solution here?
So we engaged a lot of stakeholders on this project. As mentioned before, we had a great relationship with the central plant staff and especially the director. He could clearly communicate the needs of the facility, but then we also engage other stakeholders such as vendors, such as folks higher up in the university organization. These stakeholders were brought together several times for brainstorming sessions where we considered, what could be a viable solution to this challenge. And so several brainstorming sessions were held. Everyone contributed. Nothing was left off the table. We engaged vendors after the possible technical solutions were identified, and we asked them how their machines would function in accordance with project requirements. And then each solution was compared across many categories, and we ranked them according to the appropriateness for the solution for the project. The categories included things like reliability, installation, maintenance, cost, and especially, like I mentioned earlier, we really were interested in not stranding this asset that the university was going to pay us a significant amount of money for. So all of those categories were identified, were scored, and then the diesel rotary uninterruptible power system, it ranked the highest, and so therefore it was selected and agreed upon by all the stakeholders.
Interesting. So you took a very methodical approach in terms of like laying out the different initiatives or the different aspects of the project so you can kind of attack them, in the best way forward, which I think is a great way when we talk about work breakdown structures and taking all the different tasks in your project and really breaking them down. When we do our PM training programs, we can't emphasize enough the importance of having a real clear scope at the beginning of your project, right? And then also having a real clear understanding of all the stakeholders involved and how closely you need to manage each one of those. So for example, in Brad's case, it was great that they had the plant manager who's obviously a stakeholder, but also in this case, a very helpful stakeholder who was able to communicate information about the plant, help, I'm sure, Brad make better decisions based on having the knowledge that was necessary. So, these are two critical aspects of any project: is breaking that scope down, understanding all the different initiatives you need to tackle on your project, and then who's going to be able to help you with each of them, right? When those stakeholders come into play. So again, this is a great case study for that. Now, Brad, you mentioned this earlier that another challenge was the limited plant footprint for the new generator and steam turbine, as well as space for significant boiler and control modifications. So talk about that challenge and the solutions that were arrived at there.
Yeah, and similar to the selection of technology, we engaged many stakeholders in this. We did an options analysis, looking at all the different areas that could actually house this DRUPS. And keep in mind, a diesel rotary UPS system consists of a flywheel, a generator, and an internal combustion engine on one skid. So this is a fairly significant piece of equipment. We're talking about a 30-foot long by 10 feet wide and 10 feet high piece of equipment that weighs 50 tons. So it's a significant piece of equipment, and finding space for that along with the supporting electrical gear is a challenge, especially in a plant that's a bit older. It's been added on to. Some of the structure is not quite as clearly defined on drawings as you would hope. And so we're looking at potentially placing this outside in an additional building. But what we did through the options analysis and examining each one in concert with the plant staff was we actually learned that we could put this in a fairly open area where a exhaust stack had been, and so because of the fact that there was an exhaust stack there was a significant foundation that the drops could sit on, and that worked out quite well. We still had some challenges with getting all the gear in this space because again, the this was a significant amount of switch gear and control cabinets, as well as the arc flash duct had to be routed outside, and so that was a challenge as well. But we worked together with the drops vendor and with the plant staff, with the contractor, and through that collaboration, really came up with a good solution. One key aspect of this is that with every engineering decision, there are obviously many effects on the contractor and the plant staff. And so making engineering decisions with constructability, with maintenance, with ergonomics in mind was also a significant key for the boiler and control modifications that occurred with the project.
That's great. And I'll just add to that last point, which I think is really important. We work with some design firms that actually a couple of firms that are more like design build. And what they do is every periodically through the design process, they'll have the construction team do like a constructability review as they're designing the project, to Brad's point, which can be really helpful because sometimes designers don't really think about the construction side of it as much for whatever reason. They're not exposed to it enough. They don't have knowledge enough around it. And they think we could just, it fits on AutoCAD here, so we could stick it over here, but is it really going to work when it comes to constructability? The other follow-up question I have on that, Brad, is, because this comes up a lot in our PM training sessions, is when you have a situation on a project like that where, it's tight and you have to really figure out how you're going to design something, how you're going to fit it in there. When you do the contract for something like that, do you offer a certain number of alternatives, or do you just kind of have enough in your budget, in your design budget, to try some different things that you can approach to the client? I don't know if you can speak to anything about that, but that's always an issue I find. If you start doing a bunch of different alternatives, is that cutting into your budget quite a bit?
Yeah, so we do, in this case, on this project specifically, we ended up budgeting because we knew that there were going to be some alternatives that needed to be considered. And so there was some alternative analysis that was engaged in. Keep in mind that our direct contract was actually with the contractor. This was a design build contract. So we could work closely with our client, the contractor, and they didn't have any issues with us providing value added options for them. They were happy to pay us for that. And so because of the contracting structure and the open and honest relationship that we had with the contractor, and I should mention their name, that was McKinstry. They're out of the Pacific Northwest, but they are a national firm. Great to work with, great guys, very knowledgeable. And so had a very healthy team aspect where we could openly communicate about different options, especially options that would save them money and allow them to complete the work safely.
That's great. And that really leads me perfectly into the next thing I wanted to ask you about. We know that collaboration is key in complex projects like the UW upgrade here. You talked a little bit about it just now, but generally speaking, how did your team coordinate with other disciplines, stakeholders, the contractors? Like, what did the communication workflow look like? Were there regular meetings, as needed meetings? Just take us a little bit kind of behind the curtain on how the communication flowed through the project.
Sure. And so I'll have to mention our direct client again. So McKinstry had an agreement with the university, and so they were at the center of the communication hubs, so to speak. They really did an excellent job of setting the tone for the project. The team dynamic was very healthy, and they were great at setting up not only brainstorming meetings, but also encouraging us to reach out directly to plant staff, to vendors, to their subcontractors, to try to mitigate any risk, raise any issues. And so that the collaborative environment that they set up and the tone that was set up really early in the project helped helped the project execution, and they were just a great firm to work with, and really appreciated how they allowed open and honest communication.
That's great. Yeah, it's such an important aspect of your project, being able to communicate the information effectively and productively without under communicating or over communicating. There's kind of a fine line there when a lot of people are busy and have a lot going on. So that's great to hear. So, Brad, what do you think were the most important lessons learned from this project, both in terms of engineering as well as project management? And how can maybe some of these insights be applied to future scenarios when you're planning for zero carbon solutions?
Yeah, sure. So I'll start with the project management aspects, and I'm going to harp on this again, but I I think stakeholder engagement is huge. If keeping the folks that are true stakeholders, and keeping them involved in ensuring that they're communicating the requirements throughout the project lifecycle is huge. Also, the brainstorming sessions helped with that. And regular meetings. There were meetings for the design team. There were meetings just with the executive and project management team, and those sessions were really helpful in keeping everything on the table and the project moving in the right direction. I also really appreciated the contracting structure that UW had set up. They functioned under a construction manager at risk. And some of the benefits to that project management model was that it it was an open book with McKinstry. And what that allowed was the visibility into how the budget was working on the contractor side. In fact, the project came in, it was projected to come in under budget. So that allowed the end user to add some scope to the project, to add value to the project. And that was a great idea, a value added solution, and just evidence of the forward thinking ideas that UW had in their contracting structure. The project did come in right at budget, but it was for a bit more scope than had planned. So that's just a huge value to the end user and the university. On the engineering side, really, anybody looking at doing this in the future should plan to select a technology that's modular in nature, that can be translated to future phases of a university's lifespan. And again, as mentioned earlier, there's a significant movement toward decarbonization, but yet the plant still has to function. The plant still has to be reliable. The plant still has to provide power and energy to the hospital. And so having a technical solution that's modular in nature, that allows it to be translated to future phases of the campus energy plan is really important when we look at implementing zero carbon solutions.
That's great. And I'm glad you talked a little bit about the construction manager at risk, because I know design build has been around for some time now, and there's been many high profile projects across the country and beyond that have done very well with design build. But I also know that, sometimes it gets a bad rap because people think like, hey, the engineer shouldn't necessarily be working for the contractor directly. But I think the way you laid it out here shows that if you have a contractor that is really good at what they do, it actually could be a huge benefit, because now you have the design and the construction kind of working on things during that design process, which is only going to make the construction process smoother. And it sounds like, you know, McKinstry was a really great collaborator with all stakeholders, which really kind of made the project happen. So, if you're a PM out there and you're nervous because maybe you're getting into your first design build project, hopefully some of these things that, Brad mentioned here can help you kind of get ahead of it as you go through. So the last question I want to ask you here in this segment, Brad, and then we'll do our pitfall segment. For AEC professionals looking to tackle similar challenges, what advice would you give them about fostering innovation within their engineering teams while they're managing the risks associated with implementing unconventional solutions? Because I know Stanley's really big on innovation.
Yeah, I'll tell you what, I think the first thing that we need to do is acknowledge that I may not be the smartest guy in the room, but I know where to find them. And that I think is huge. If project managers and project teams can recognize subject matter experts, engage them and retain them in the project, I think that's going to be huge for implementing unconventional solutions. Keep in mind that, the SMEs could reside within the AE firm, but they often don't. Owners have great insights into what systems they have, how the systems behave, what the best nature of the solutions will be. And then, keep in mind, contractors install equipment all the time. And so, especially when considering unconventional solutions and having innovative ways to put things together, they're experts at what they do. Ensure that they're engaged, ensure that they're an integral part of the team, and they're vendors as well. Key equipment vendors have tons of insight into how to install their systems, how to install their equipment, where their equipment functions best. And so, I view vendors as a great way to implement unconventional solutions, because they're looking to improvise just as much as we are. So they're a great add to the project team.
That's great. Yeah, and again, it comes down to, leveraging all the possible parties and stakeholders that you have involved in your projects to get the result that's intended. Obviously, a project that's on budget and on schedule is always what we're going for. So, all right, we're going to take a quick break. I'm going to come back with Brad, and we're going to finish up with our PM Pitfall segment. We'll be right back. All right, we are back with Brad Schmidt. Brad is the Power Mechanical Department Manager at Stanley Consultants. He talked a lot about an interesting project today, the Design Build UW project. But now we're going to wrap up our episode with our PM Pitfall segment. So, Brad, what's the biggest project management pitfall that you've seen in your career, and how would you recommend PMs overcome it or try to avoid it when they get into these challenges on their projects?
Yeah, sure, Anthony. So I don't think it's going to come as any surprise, but honestly, I think the biggest PM pitfall is stakeholder engagement. If we don't, as PMs, understand who the stakeholders are from the very beginning of the project, make sure that they're engaged, make sure that their requirements are being communicated to the project team, make sure that they stay engaged, we really don't have much hope of meeting a business case, meeting the objective of the project. A project could be executed flawlessly, but if we don't have the right requirements that come through stakeholder engagement, we're going to be shooting at the wrong target. And so that's why I think stakeholder engagement is huge. Don't forget that end users are key stakeholders. Equipment vendors are key stakeholders. If they're not engaged and fully engaged throughout the entire project life cycle, it's really a big risk to the project.
Yeah, absolutely. And that's why when you start your projects, we always tell PMs one of the first steps that you need to take is to identify all of your stakeholders. And we'd like to say prioritize them, in that some of them will be more interested in the project and more influential than others, which is also good to know because, again, you have a limited bandwidth. So if there are 50 stakeholders on the project, you're not going to be able to give all 50 the same attention. So you need to be aware of, if it's a local politician that's very interested in the project and influential, you might need to spend a little more time managing that stakeholder than maybe just a general taxpayer or whatever the case may be. So again, a big part of project management. We're thrilled that Brad was able to come on today and take us through his project so we can really focus on stakeholder engagement and some of the unique challenges that they faced. Brad, thank you so much for spending some time with us here today on the AEC Project Management Podcast.
My pleasure. Thank you for having me.
I hope you enjoyed my interview with Brad. There is no doubt that stakeholder engagement is one of the most important aspects of successful AEC project management, and he gave us some great tips to be successful today. If you enjoyed this video, please subscribe to our channel here. We put out videos like this on a weekly basis to help AEC professionals become better project managers and leaders. I'll see you next week.